Hey guys, we're starting with 12.2 radian angle measurement. So this is a good topic for the regions. They ask you to convert from radians to degree or from degree to radians. So just as distance can be applied in feet, miles, inches, centimeter that you did in geometry, the rotation can also be done in terms of radians or degrees. So we can convert measurements from degree to radians, or we can go from radians to degree. So a common unit for angle measurement in Algebra 2 is alternative to degrees is something called a radian, which is basically the arc length of a circle and the circle radius, as shown below, looking at this diagram right here. So the definition of a radian: the radian angle theta created by the rotation about a point using the radius of r passing through the arc length s is defined as blank. So we have theta is equal to s over r, or s is equal to theta over r. Now, before we do anything, I want us to consider two things. I said, what is the length of s in terms of the radius of the circle r on a full rotation? A full rotation meaning it's a complete rotation, it will give me a circle. I want to know what is s equal to. So s is actually my circumference, which is my circumference of a circle is 2 pi r. So s is equal to the circumference when you're talking about a full rotation. Now, looking at this, it says, based on the definition above and your answer in part A, this is here, how many radians are there in a full rotation? So a radians in full rotation. So when you want to find a radian, remember this is the formula I'm going to use. So it's going to be theta is equal to s over r. We actually know s, based on what we found, was 2 pi r. The r's cancel, so a radian is going to be in 2 pi. So radians are essential measure to the total number of the radii, hence the name. They has transversed about the circumference of a circle, and based on the circumference of a circle, there will always be 2 pi radians in a full rotation. This is what we need to remember. There will always be 2 pi radians in a full rotation. So exercise 2. Use the formula above to answer the following question. Determine the number of radians in a minute hand of a clock that passes through the length 5 and the tip travels at a total distance of 13. So in this case, my radius is 5 and 13 is my s. Okay, think of a clock. The radius is 5 and the hand travel 13. So I'm saying, what is this piece? What is this theta right here? And r is equal to 5. So go back up here, it's theta is equal to s over 5. So when I do this, I'm actually getting s is equal to 13 over 5, which is the same as 2.6. Now for B, it says if the pendulum swings at an angle of 0.55, what is the distance as it travels, as the tip travel in a length of 8? So what am I given? So I want to find the distance. I want to find s. So r is equal to 8, and I know theta is equal to 0.55. So s is actually just multiplying these two numbers based on my formula up here. Multiply this out, you will get a 4.4 feet. My answer is given in feet. Alright, let's look at some more example really quick. Radians are essential in the study of higher level math and physics, and are the angle measurement choice for the study of calculus, which some of you are going to take later. It is important to be able to convert between an angular system of degrees and that of a radian. The next exercise will help you do this. So this is where we go from degrees to radians. Now it says, consider 1/2 of a full rotation. So remember we said a full rotation was 2 pi, right? Or 360 degrees. What is the angle measurement both in degrees and radians? So now we're talking about a half rotation. So a half rotation is something that looks like this. So in terms of degree, half rotation is 180 degrees. And in radians, what do you think? What's half of 2 pi? Half of 2 pi is actually pi radians. Okay, now just really quick, anytime you're dealing with stuff on pi, the calculator should be in RAD mode, and when you're talking about regular, it should be in degree mode. Okay, if you're not sure on how to get these change the mode of the calculator, please make sure you see me, okay? Now, this question says, using the two equivalent angles in rotation, A, convert 360 degree angle to the equivalent radian. So, now to convert, and this is where it goes. So I'm going from degrees to radians. It's pi, oops, not pi, theta is equal to, 30 times pi over 180. And then we're going to simplify this. This is actually 30 pi over 180, which is the same as pi over 6 radian. And this is my answer converted to radians. So let's get rid of this. The formula now to convert, did I give you the formula? No. So the formula from degree, please make sure you have a note, to radian is the angle times pi over 180. So whatever angle or theta is given, you times it by pi over 180. Okay, so now what if I will ask you to go from radian, and just make a note of this, I thought I wrote this out, radian to degree. So when you're asked to convert from radian to degree, it's going to be the theta that they gave you in degrees times 180 over pi. So if you notice the last one, it kind of interchanged. We're going to see that in example 3 and 4. So I'm going from degrees to radians. I want to convert. The first one says, express your answer in terms of pi. So from degrees to radians mean I multiply by pi over 180. Okay? Up here, pi over 180. So I will do the first one. So your new theta will be 90 times pi over 180. Multiply across 90 pi over 180, which is the same as pi over 2. And because it's radiant, you have to write the RAD so that we know exactly what you're talking about. Now, I want you to pause the video and try B and C on your own. If you got a chance to try that on your own, you should have gotten 2 pi over 3 radians and 5 pi over 4. Here, let's see, theta is equal to 5 pi over 6 times 180 over pi. So here we're going to have 900 pi over 6 pi. The pi's cancel out. 900 divided by 6 is 150. Remember, you have to put the degree sign because now I'm working with degrees. Go ahead and try B and C on your own. So B, you should have gotten 270 degrees, and C should be 135. Now you should feel very comfortable with this. We have 2 more exercises to go here. So we have, the first one said, convert each of the following radians, which aren't in terms of pi, into degrees, and round it to the nearest degree. So this is very similar to what we did. This becomes pi is equal to 5.8 times 180 over pi. You put this in the calculator, you would get 332.315, but it says rounded to the nearest degree. So to the nearest degree is approximately 332 degrees. So all this is similar to this exercise here, 4, but only now we don't have anything to do with pi. So like this one here, we'll have theta is equal to 4.2 times 180 over pi. In the calculator, this will be 240.642. Nearest degree is actually 241 degrees. And then we try the last one, try C by yourself. You should have gotten negative 143.239 and so on, which is rounded to 143 degrees. Last one before you guys go. An angle is drawn in a standard position whose radians measure 2 radians would terminate in which of the following? So first of all, I need to know we have a measurement that's 2 radians. In order to find out what quadrant this is in, let's convert this. The easiest way is degrees, because we all know how to sketch and graph degrees. So theta is actually going to be 2 radians, and I want to convert it into degrees. So this is, this is into 180 over pi. This is actually 114.59, which is approximately 115 degrees. Now looking at my quadrant, remember your quadrant go counterclockwise. This is 1, 2, 3, and 4. 150, I know this is 90, so 115 would be somewhere on this side here, which will be in quadrant 2. So that's how you see the question on the regions. One thing I want to just point out is on the regions, they may ask you, so something like this, they may ask you to convert 2 radians, and this is on a side note, to degrees and minutes. So just like what we did, theta is equal to 2 times 180 over pi is equal to 114.59. I'm only taking the 2 digits. So now, how do you take this 59 and you convert it into minutes? You can do all 3 numbers if you want. That's perfectly fine. So we need to remember 2 things. There are 60 minutes in 1 hour. Okay? So I need to convert this into minutes. So what I'm going to do is, since there's 60 minutes, I will times that by 0.59. So 60 times 0.59 will give me 35.4, which is approximately 35 minutes. So my final answer when we write this would be 114 degrees and 35 minutes. I think the symbol is just one. It's not the word spelled out. It's just that one little mark in the top. Alright, so this is on a side note. Sometimes they bring this up to convert it to degrees and minutes. Okay, all you do is take the numbers after the decimal and you multiply it by 60. Alright guys, go ahead and practice those problems. I will see you when you're done. Good luck.